My name is Rupert Mack. I'm the director of Mediclean. Mediclean actually stands for Infection Prevention and Control in hospitals. I'm personally more than 30 years familiarized in the ventilation system, in ventilation in hospitals. I'm a member of the European Committee, TEC 156, Working Group 18, as well as a member of the German DIN Standard 1946/4. We are actually a German company, but also based and located here in Loughborough, around the corner, so to say. The question is airborne bacteria, airborne viruses during Corona times. Air as a transmitter of viruses has been gaining an important role during the pandemic. Also, the World Health Organization mentioned that they acknowledged that the airborne transmission of coronavirus may be a threat in indoor spaces. They say that possibly airborne transmission cannot be ruled out, but I think now it's proved that airborne transmission is an issue. And they speak about appropriate and optimal ventilation. So, and the question which derives from these sentences are, what about operating theaters instead of indoor spaces? What about airborne bacteria and surgical smoke? Surgical smoke is also an issue in operating theaters. And what is actually the right ventilation in order to have a best practice in infection prevention? So it helps a lot to understand what is about the filtering, and the European Center of Disease Prevention and Control, they made this table here, and this table shows that what is common, what is in terms of ventilation used in hospitals, outside hospitals, office buildings, as well as shops, restaurants, and so on and so on. And this graph, this table clearly shows that for operating rooms, for hospitals, HEPA filters are more or less a must in order to wash out aerosols. And they differentiate aerosols and droplets. In a talk tomorrow in the morning, I heard the pop size. He mentioned pop sizes, and here the pop size bigger than 5 microns. They speak about droplets, and smaller than 5 micrometer. They speak about aerosols. And this table shows clearly that for hospitals, it's more or less a must to have HEPA filters in order to have the best practice in infection prevention. Now we come to the infection prevention for the wound infection. And here it's good to know that we have two types of ventilation that the physics offers to us. It's the question is mixing or displacing, and the left picture shows the mixing ventilation. The dots shows that in the mixing ventilation, bacteria, pathogens, everything, particles, viruses, microbes, bacteria, are in the whole room the same concentration. And on the left picture, you see the unidirectional airflow. the unidirectional airflow shows that you can make sure that you have a protection zone, as you can see here with the dots. The dots are outside of the protection zone, and the protection zone has to cover, according to the standards, the wound area, the instrument tables, as well as the personnel, sterile closed personnel. So if we follow if we follow the ECDC table, there is a must to have filters inside, filters here in the diffusers or here in the ultra clean plenum, where all over the surface HEPA filters are included. So the question is, what is the difference in between mixing flow and unidirectional airflow in terms of viruses? In terms of viruses, we can not find any study, but I can show you a nice study about bacteria, airborne bacteria, and it's all about airborne ventilation. The study shows that there were some measurements done in terms of bacteria, as you can see here on the Petri dish. And the interesting thing here with this study was that the team moved from a dilution mixing airflow operating room to an unidirectional airflow room. And the result was that unidirectional airflow reduces airborne bacteria more than 90% compared to the dilution mixing airflow system. So we can assume that the same result is in terms of viruses, considering that if there are particles inside, viruses can sit on the particle, bacteria can sit on a particle, or nothing of them. But this study clearly shows that the unidirectional airflow makes sense in order to have the best practice in terms of infection prevention. So, as I said, an ultra-clean ventilation system has the goal, has the task to make a protection zone that covers the wound area, instrument tables, as well as the sterile closed personnel. So, but an operating room is not a sterile and empty room. It's something like this here, where 10 and more people are working inside. And these workers, doctors, nurses, they are confronted with bacteria, with viruses, as well as surgical smoke. Surgical smoke, you know, it comes from HF surgery. Surgical smoke is considered as quite hazardous. It's some say it's worse than smoking, and considering that a non-smoker has to work all day, 8 hours a day, as a non-smoker inside an operating room, this is not the goal of everybody. So these three substances are inside the operating room, and then the question is, how can we solve or improve the situation? And considering the industry, whether it's pharmaceutical nor it's semiconductor industry, they have more or less as a standard, they supervise parameters, temperature, humidity, number of particles, whatever. So it's shown that there is, if there's something out of limits, they stop production or they change their behavior, and it could be a learning effect here in this case. And the question is, what about operating theater? As far as I know, and I'm, as I said, familiarized more than 30 years in the hospital ventilation business, there is no signal that shows something out of limits. There's no control. I mean, there is, of course, temperature and humidity controlled, but it's no sign whether it's out of control, and numbers of particles, they are not shown, and other things are also not shown. So the question is, how can we improve the situation? And linked to the industry, to how they do and have the solutions for this, we can discuss whether it makes sense to supervise the particles close to the wound area. That means on the instrument table. We can discuss whether it makes sense to protect the noses of the surgeons. If I was a bacteria and wanted to have or wanted to achieve an infection, I would choose the way via knife, via scalpel, where I can come surely into the wound area. So it's not done yet, but it could be easily done, technically wise. You have a section where you measure the number of particles. You can show whether it's good or whether it's not good. And if it's not good, you can speed up the air volume in order to wash out the unwanted substances as quickly as possible. And UCV canopies like this here work more or less in such way that there is a certain amount of fresh air and there's a certain amount of additional recirculating air. And as long as we bring it via HEPA filters into the room, there's nothing against it. So, and if we say, let's do it needs-based, that we have that much air volume that is needed to have a low particle concentration, we can do it in that way that we speed up the air volume flow if the number of particles go up. So as you can see here, the particle device measures a high number of particles, and then we speed up. We show that there is something too high particles, and we speed up the fans and the air volume flow in order to wash out viruses as well as particles. So this could be a principle. Yesterday, during the talk of Frank Mill, he complained that there are not so many innovations at the moment in the market. This could be a solution, that we have a needs-based technology. And now I come to a point that is really not that easy because it's historically driven. The different standards. There are big difference in between the different standards. Here, this table shows the German standard compared to the UK standard, and as well as the ASHRAE Standard is 170, not 70, sorry. And it shows that there's a difference in between there's a big difference in between air volume flow. So the question is, what is the right air volume flow? So there's more or less in the European Committee, as I'm a member, I said, there's more or less a common understanding that if operating rooms with high demands in surgery and infection prevention, as heart surgery, neurosurgery, orthopedics, that it should be done in an ultra-clean ventilation environment. So, but here you can see there are different demands in fresh air, 10 air change rate in Germany, 22 and more in UK, and 20 in America, as well as the velocity, 0.25 in Germany, 0.38 meter per second in the UK, and only 0.127 in America. So the question is, what could be the right volume in order to have the best for patients and personnel? Why do we have in Germany 0.25? According to measurements or to our knowledge, we know that an upstreaming of the body heat is about 0.2 meter per second, and it's more or less 20% security. It's upstreaming and 20% plus from the bottom coming down. It's that why we came to 0.25 meter per second. I have spoken about needs-based. So, and the idea is, if we say, okay, what is our goal? What is our aim? To have the best for the patient and for the personnel working inside the operating room. Maybe we come out to an agreement that the particles is the right point we have to address to, because of particles they can sit bacteria, viruses, surgical smoke as well is a particle. And this shows one excerpt of a measurement during operation, during a real operation. There's a set point. The set point of particles is 100. Why 100? 100 is, according to ISO 14644, it's sterile. It's class 5. 100 particles, according to, is equivalent to class 5. So now we say, okay, we want to achieve class 5, and we made measurements close to the instrument table, and the measurement shows zero particles, and then there was a jump to 158 and 250,000, 190,000. This came with surgical smoke. No one can expose, no one can produce that much particles within 1 or 2 minutes. So, and then from the principle, I mentioned that we speed up the fan if there is the number higher than 100 particles. 158 is higher than 100. So the system begins to rise up. And the fan activation was 50%, then 53%, and then 65, 74. So that means there is a flexible system reacting on the particles we measure. And we believe that this could be a different thinking. Yesterday during Frank Mills' talk, we have to think different in order to improve in hospitals. Considering and knowing now that that airborne transmission is real. Believe me, before Corona times, it was horrible to talk about airborne, whatever. But now everybody knows what is behind airborne transmission in terms of viruses and bacteria. So we believe that we can help to improve the patient safety, fewer particles and fewer airborne germs, help to improve hygienic behavior among surgical staff. Up to now, nobody knows what happens with their behavior in the operating room. Nobody knows. Whether they are dancing around or they are good behavior or bad behavior. With a signal, you can show what is the result, what they are doing. Help to correct interfaces such as technology-wise, doors, lights, pendants, or the personnel, is it the right clothing, is a mask sitting right well. And last but not least, energy saving. Yesterday, again, I learned from Frank Mill that in UK, nearly half of hospitals do not follow the standard. Maybe it's about the energy costs, it's about the energy consumption, and maybe it could be a good way to think about particles, think about what we try to avoid, and think about need-based solutions. Even control setback or switching off hospitals, the ventilation of the hospital. You can switch off, and then after switching on and getting green light from the system, you know that everything is fine and you can operate again. It's an idea. So if you are interested in that, feel free to visit YouTube. We have a nice video, explanation video about this, what I was explaining to you, and I'm sure that digitalization can help in patient safety, workplace safety, as well as energy savings. Now I leave the operating theater and I enter the surrounding rooms. Surrounding rooms could be dialysis center, patient rooms, examination rooms, CT, MRI scanner, angiography laboratory, and many more. So everywhere where heat load, where too hot temperatures cause an non-hygienic surrounding. And also here the question is, and this slide is joining us during my presentation, what is the right thing of ventilation? And here clearly, not in every case, unidirectional airflow is the right one. For those rooms with CT scanners and so on, it makes sense that we have a mixing airflow. And by the way, DMAF and UDAF is a future abbreviation also in the technical specifications that is supposed to be ready by the end of this year. So if we have this, just to let you know, the need for those units is from the first demand, cooling. It's too hot, we have to cool. So what is the right way to make sure that we have no viruses, bacteria, and molds in these recirculating units? A first thing could be that you have silver iron coated surface. Also, the old Egypts know that silver has a sort of antibacterial working. So it's one option to avoid that bacteria and viruses can live or live longer in such a unit. And then this again this table that emphasizes that if you want to wash out viruses, aerosols, bacteria, and viruses and bacteria are very, very small. They are smaller than 5 microns. You have to have, if you want to wash out those aerosols, HEPA filters inside. So that means that normally there are 2 filters inside. The first filter protects all components inside, and the second filter assures required supply air quality. Along with COVID, the demand for a higher air quality come up, and so there is also the possibility to have a HEPA filter inside this recirculating units. So together and in combination with HEPA filter, some said, oh, here, if I have to change the HEPA filter, it's not that healthy, considering that there are viruses and bacteria landed on this HEPA filter. Most of them go through. If you have if there's no HEPA filter, just an 85 filter and so on. So in combination, it could be done that we have a HEPA filter, an UVC light for the HEPA filter. And then the subject is cooling, surround recirculating units. They cool in the first approach, the first task is to cool. And cooling means dehumidification. Dehumidification means water. Water can build a biofilm, especially during shut-off periods, considering there's a long weekend now and they shut off the unit because there is no heat inside on Fridays, and after a long weekend they switch it on again on Tuesday. So the biofilm has time to grow, and this is we have to avoid, because after switching on you smell more or less the mold. And the good idea is to have a so-called thermal disinfection. With this thermal disinfection, you heat up the components that are in contact with condensates, means a trip tray and heat exchanger, the cooler. So you heat it up 70 degrees, 10 minutes, and it's enough to make it dry and to avoid that any pathogens, viruses, bacteria, and so on, molds can grow and more or less develop. So this should be, if this is the case, and a hygienic person who is responsible of the security will find this, he will shut the room. It's not acceptable. But this is a real picture of a cooler where molds and whatever was growing. So the units can be installed preferably within the suspended ceiling, so there is no obstacle for any other installations. Mostly as a recirculating, as you can see here in the left grill here is the suction side, and here the diffuser is the pressure side. And our subject is also how to control. Nowadays, with the new technology, there is no problem also in terms of in terms of predicted maintenance. You can get all the information about all the components inside, whether valves or polluted filters and so on and so on, and you can easily get the information that the filter should be changed in a couple of days or in the near future. So if you are interested in those recirculating units with, we call it four-level safety concept, please feel free also to go into the YouTube channel and where we show what is the idea behind. Last but not least, now we leave the wound infection section, more or less, and we enter the respiratory infection. Respiratory infection is about the viruses, and this could be also a subject in your hospital, where you make trainings, academies, and so on and so on. And we believe that here a layering ventilation can really help to avoid infection respiratory-wise. As layering ventilation, as you can see here, fresh air is brought in close to the floor. And with the body heat, as I mentioned before, the body is a bit heat exchanger, so it causes upstreaming heat. And with this upstreaming heat, you bring up the viruses as well as CO2. And this is then the question, or if you want to have a sustainable solution, whether such a solution can help. So again, we compare this both flow pattern, mixing ventilation seems not to be the best solution in terms of respiratory infection prevention, because we want to avoid that there is a cross-contamination from one person to the other person. And so we try to manage that, as these pictures should show that there is no, if here the lady in between is infected, that they do not infect the other people around. So with this layering ventilation, we believe to have solution where you can reduce viruses as well as CO2. This system works with 100% fresh air. There's no need for a HEPA filter inside. That means that what you bring in, you bring out. And then again, the subject is needs-based, not more than it's necessary, but the level you need. It could be done easily with CO2 measurement. A possibly scenario could be the room is empty, there's nothing inside, and there's nobody inside. And then you have a sensor that recognizes people coming in. the air volume speeds up to the maximum, and then the CO2 measurement starts. And according to the CO2 measurements, we calculate the number of people, and so we automatically fix the ventilation flow in order to have a needs-based ventilation. And this is, from our point of view, also could be an innovative solution. The question, the process is to identify the needs, regulate the needs, and show whether the concentration is good or bad. And if bad, we automatically speed up the fan speed, as I explained, similar or the same, more or less, in the operating room. So this is could be an interesting idea and new solution in order to reduce viruses, and everybody nowadays knows what this is about, viruses and the threat coming from them, as well as the CO2 subject.